Hey guys, in this video I'm going to be working out with you some of the probably odds, maybe some evens from your final exam review so that way you can do the other part by yourself. So a big part of this review is about transformations, and if you remember with transformations there are different parts that cause different transformations. Let me show you what I mean. Okay, so here we have an equation. This is an example of the square root equation. Okay, remember the h and k, we've talked about this many times this year. The h and the k are the vertex. The h moves it side to side or left to right, and the k moves the graph up and down. Okay, again, we've talked about this probably 1,000 times this year. Okay, so the h moves it left to right. Now remember, if it's x minus, let's say 3, that actually makes it go right 3. It's kind of the opposite of what you'd expect. If it was x plus 3, then that would go left 3. So this one moves it left to right, and the k moves it up or down, and it's exactly what you'd expect. Plus moves it up, minus moves it down. The a affects how wide or narrow the graph is, and also if it's reflected. If it's negative, it's going to be reflected. So let's look at this here. So it says we have f of x equals the square root of x, and g of x equals negative square root of x plus 5. Okay, so we're going to graph both of those on the same grid. Okay, so I'm just going to create some ordered pairs in my head here. So if I put 0 in for x, the square root of 0 is 0. If I take the square root of 1, the square root of 1 is 1. And then you can't take the square root of 2 unless you want to get some really ugly number. You can take the square root of 3. The square root of 4, though, 1, 2, 3, 4. The square root of 4 is 2. 1, 2, 3, 4. Okay. So this is what the square root graph looks like. And you cannot take the square root of a negative. So that's why there's no points over here on the left side of the graph. Okay, so that is the square root of x. Now, if you take the square root, the negative square root, and you also go 5 to the, let's see here, so x plus 5, so that would be left 5. So it's going to go left 5, and it's also going to flip over. Let me go ahead and graph that for you and so you can see the difference. Okay, so it's going to be left 5, so you can 1, 2, 3, 4, 5. And then this point here, so it's going to be left 5, but it's also going to be reflected over the x-axis, so that point's going to be down here. And then same thing, it's going to be reflected over the x-axis, and it's going to go 1, 2, 3, 4, 5. Okay, so this is what the graph would look like of g of x. Okay, remember this one up here, that was f of x. Let me go back and label that. This is f of x, and that's g of x. And again, all I did was I flipped it over the x-axis, the negative sign flips it over the x-axis, and then I shifted it left 5. Okay, so write a verbal description of the transformation. So it went left 5 and reflected over the x-axis. Okay, so for the domain and the range, let's just concentrate on this green one here. So remember, you can't take the square root of negative, so the domain is 0 to infinity, or you could say x is greater than or equal to 0 for the domain, and also the range is also x is greater than or equal to 0. Or, sorry, y, we're talking about the range. Okay, now for g of x, it flipped over and it also went back 5. So the domain is x is greater or equal to negative 5, and the range, because it's going down now, is y is less or equal to 0. Okay, now I'm not going to work out all 6 of these right here. I'll work out maybe a couple with you. Let's talk about this one right here. So even though the type of function has changed, this is now an absolute value, you still have an h and a k, and you still have an a value. So here's your a, here's your h, and then your k is out here. It's just 0. Okay, so let's talk about this. So it's going to be 3 to the left. It's not going to move up or down because the k is 0. -2. Okay, the negative is going to reflect it over the x-axis. And then the 2 is going to create a vertical stretch. Remember, if that number here, the a, if it's greater than 1, it's going to be a vertical stretch. If it's less than 1, like half, then it's a vertical shrink. Okay. Maybe just one more. Let's look at number 9. Okay, this is an exponential function. I'm sorry. Yeah, I'm sorry. It is an exponential function. Okay, so we have a 1/2 here, so that is the a. And since that is less than 1 whole, that's going to be a vertical shrink, like I was just talking about. Okay, now this looks a little bit weird, but you do have an hk. This would be your h, and then your k would be 0. So this is going to go right 4. Okay, so knowing that, I think you guys can do the rest of those on your own. Let's move on. Let's see here. Let's talk about, I think you can do the function family on your own. Let's look at the inverse functions because it's been a while since we've done inverses. Okay, so find the inverse algebraically. We have a cubic function here. So remember, when you're finding the inverse algebraically, the first thing you do, I'm going to kind of show my work here and then go over here. First thing you do is you change f of x to y. And then remember, you switch x and y. So I'm going to go ahead and do that over here. So you switch x and y, and then you solve for y. So in order to solve for y, you're going to have to subtract 3. And then we need to cancel out this cubic here, this third power. So the inverse would be raising each side to the 1/3 power to get rid of that. And I don't know if you remember from before, but raising to the 1/3 power, that's the same as a cube root. So we have the cube root, make sure you write the 3 out there, of x minus 3 is equal to y minus 1, and then we would just add the 1. So our inverse, I'm going to go ahead and start writing that. Our inverse would be the cube root of x minus 3, and then you have to plus the 1 to the other side. So that would be the inverse. Okay, it does want you to graph them both on the same graph, and I'll let you guys do that. You could use your calculator for that, and then also you can look at the graph, get your domain and range. Okay, for number 21, it says show the 2 equations are inverses by using compositions of functions. Okay, so for this part, in order to verify that they're inverses, you're going to basically plug one function into the other. So, coming back up here, we're going to take this function here, the inverse, and we're going to plug that in for x over here back in the original function. So we're just going to take all of this and plop it in for x right there. So it'll look something like this. Oh, you know what? I just realized I made a little tiny error up here. I don't know if anybody noticed this. I don't know why I changed this 4 to a 3. So that's okay. I'm just going to go back and edit that. So that's a 4. Sorry. I bet some of y'all noticed that, and I just kept going. Okay. So when I write this down here, plus 1 minus 1 plus 4. Okay, so what I'm doing is I'm taking all of this and I'm plugging this back in here. So for x, instead of x, I put the cube root of x minus 4 plus 1. And then we also had that minus 1, so that's why there's a minus 1 right there. And then we have the cube plus 4. Okay, so when you do that, when you plug one function into the other function, so I just plugged all that in for x. So what's going to end up happening here, let's see here, plus 1 minus 1, that's going to cancel out this part and this part. And then this is going to cancel this out because this is to the 1/3 and that's to the 1/3, so then that's going to cancel. You're going to get a bunch of things canceling. So you're just going to be left with x minus 4 plus 4, and then the minus 4 plus 4 also cancel, and you're left with x. So if everything cancels and the only thing left over is x, then that means that those two functions are inverses. Okie dokie. For this last little bit, I don't really think you're going to need any help with this. So again, you can use either Desmos or you can use the TI Inspire calculator, and you're just going to plug this in. And we just finished this unit, so I don't think you should have any issues with this part. Good luck, guys.